This is a 2010 4B, a smooth wedge with mass 4m of slope 45 degrees, rests on a smooth horizontal plane. Paragles with mass 2m and m are placed on a smooth inclined face of the wedge. Systems released from rest. Draw and separate diagrams to force acting on the wedge and on the paragles. Okie dokes. So have the wedge here. I'm going to rotate that around so it's like that. Okay, so we'll start off with the wedge. Okay, now what the wedge does is it feels a reaction force, so we call it them R1 and R2 respectively. R1 is what's supporting the paragle upwards, R2 is supporting the M paragle upwards, so technically that feeds R1 and R2 downwards. Now it specifically says separate diagrams, so make sure they're separate. Okay, R1 and R2. Then it's going to feel its own weight is going down as 4mg, and then it has a reaction force going up of R3 from the ground, and we'll also call the acceleration of the wedge F. Okay. Upon completion of that, then you're going to be on the M particle, or sorry, the 2m. Now, the 2m particle has a R1 going up. We're going to call this one we call it A, going across, and then we have its weight. So we're going to break up its weight into its components, horizontal and perpendicular to the plane. So that's going to be 2mg going down, and then we're going to have 2mg cos 45 and 2mg sin 45. Okay, now that's done. What we're going to do next is we've got to do the M particle of M, and I'll do this one in black. Okay. Once again, it has R2 going directly upwards. Its acceleration, we're going to assume is, we'll let it be different, okay? So, and then its weight going downwards is mg. Now we're going to have mg cos 45 and mg sin 45. Mg cos 45 perpendicular to the plane, mg sin 45 parallel and driving it down the plane. Okay. Now, before we begin, alright, this is all part A done. Okay? Now, what we need to do before we begin is we need to start thinking about the reaction forces and R1 and R2 and how to break them up into their components. So you're going to make a couple of triangles before you even go into any equations whatsoever. So this here is R1 and R2, a right angled triangle representing both of them. And you can see that we jog it down, alright, so that one will be, let me see, how do we do this again? If that's alpha, that there is going at 90 degrees, that's 90 degrees there, and then I'm doing it this way, like this. So I'm just trying to re-jog my memory here of how I go about doing this. Okay. So if that's the big one, that's R1. And it has to be at 90 degrees because it's perpendicular to the plane. That will make that I have to go down around so that one there will be alpha 90 minus alpha, 90 minus alpha, alpha. There we go. Alpha there. Okay, so whatever angle that is, it will go up there. Okay, because if you're to do this out, that's alpha. That one there is 90 minus alpha, which means that the perpendicular one up there has to be alpha. Okay, So in this case it's 45 degrees, and it didn't matter anyway, but just in case it does matter, you got to make sure that you're able to do them. So that's 45 and 45. So what we're going to get here is break it up into components. Okay, and remember it's going to be R1 over root 2, R1 over root 2. It's going to be R2 over root 2, and R2 over root 2. Just it's set components, right? These are the components acting on the wedge. Now, one of the most difficult ones, okay, and I find a lot of people struggle with this, is breaking up the acceleration of the wedge itself into its components. Now, here's the way I do it, and it never fails me. Okay, what I do is I draw along the wedge. I'll draw the dotted line. I draw along the wedge, and then I shut it down at 90 degrees, like so. And I make the hypotenuse of this triangle F. Okay? And because the hypotenuse of this triangle is F, then we have two components of acceleration. First component is going to be F cos 45. F cos 45 going up. And F sin 45 going down. Now, the question asks for the acceleration of the wedge. Now, acceleration of the wedge is the following combination. You will not use the particles parallel to the plane. Why won't you use the particles parallel to the plane? Because it introduces A and it introduces B. Not good. What we're going to use is perpendicular to the, we're going to use accelerations perpendicular to the plane, because A and B don't exist. So the only thing you're going to be using is F cos 45 and F sin 45, or F over root 2 and F over root 2. Okay? So now you're going to go back down, and we're going to do our first equation. First equation, it's always good to label what you're doing. 2m particle, and I like to write it down this way as perpendicular. Okay, so perpendicular. Now, we're going to do force. Now, the force is going inwards. Why is it going inwards? Because its net acceleration is going inwards. Now, force is mass by acceleration. In this case, it's 2m times A. Now, what's A going directly down into the plane? F sin 45, which is F over root 2. Okay, so that's going to be F over root 2. Going directly down. Now what causes this to happen? It's going to be its weight minus the reaction force. And we know its weight is mg cos 45. And what is 2mg cos 45. And what is 2mg cos 45? It's going to be 2mg all over root 2, which is the same thing as root 2 mg. So it's going to be root 2 mg. And is it R1 or R2? It's going to be R1. Okay. I suppose what we can do now, on the other side, 2 cancels with root 2 to make another root 2. So this form is going to be root 2f equals root 2 mg minus R1. Okay? And that's your first step in doing the acceleration of the wedge. The 2m particle perpendicular. Okay, now we're going to do the 1m particle perpendicular. Same, nearly exactly the same system. So the 1m particle is going to be m times f over root 2 equals what's it going to be? mg cos theta, which is going to be mg over root 2. So mg cos 45, which is mg over root 2. That represents mg cos 45. And then it's going to be take away R2. Okay? Now, and we can just leave it there. Okay? The next thing we're going to do, perpendicular, perpendicular, it's the wedge. going parallel. So we're going to do the 4m wedge. Remember the word wedge. Wedge means it can actually move. So what we're going to do is find out what the wedge is, okay? So the wedge is force. Its force is driven by the reaction forces. The only reason it's moving is it has weights on its surface, and the weights are interacting via R2 and R1. We broke up R1 and R2 into its components, driving it to the right, and that's the components that are going to be in the acceleration. So it's going to be R1 over root 2 plus R2 over root 2, and that will equal 4mf. Mass by acceleration. Whole point of this is to get F. To get F, we need to get rid of R1 and R2. Now, a cheap way of getting rid of R1 and R2 would be to multiply both sides by root 2. Or sorry, divide both sides by root 2. So what I could get here is, I would end up getting F equals mg minus R1 over root 2. Isolate R1 over root 2, and I'll get mg minus f. Oh sorry, I forgot the m there, didn't I? Oh no, but I still need to leave it there because it hasn't cancelled out yet. So it's mg minus mf. Okay, that's what R1 over root 2 is. I'm going to do the same trick here, except I'm just going to put root 2 R2 divided by root 2. All the root 2's cancel. Wait a second. No, that's not what I wanted. Yes, I understand now. Multiply the bottom by root 2. All the bottoms by root 2. And that'll turn that into 2, that into 2, and that into root 2. And then bring it over, and we're going to get R2 over root 2. Ends up to be mg over root 2.
Mg over 2.
Huh? Oh, mg over 2, you're right. Mg over 2 minus mf over 2. Okay, so now we can replace in for this formula 4mf equals R1 over root 2, which is mg minus mf plus mg over 2 minus mf over 2. Multiply everything by 2, 8mf equals 2mg minus 2mf plus mg minus mf minus 3mf on the right. Bring it over to the other side, it's going to be 11mf equals 3mg, and then finally f equals 3 over 11g. Okay.